Hello my dear students, this is to inform you that we are going to start the continuation section from the chapter Atomic Structure, which is mentioned in page number 63 and 64 of your textbook. The subtopic for this session would be concept of atomic number and mass number. Coming to atomic number, you need to know that atomic number of an element is designated by the symbol Z. And atomic number is the number of protons present in the nucleus of an atom. So we can represent it Z equals to P, where what is Z designating? Atomic number, and P number of protons. We also know that since the number of proton is equal to the number of electrons in an electrically neutral atom, therefore we can represent it Z equals to P equals to E. And what is E representing here in this equation? Yes, number of electrons. However, you need to note that the number of protons plus neutrons, which are the subparticles present inside the nucleus of an atom, they are collectively called as nucleons. This we had already discussed in part 1 of atomic structure, remember? Likewise, the second point also we had discussed in the part 1 of the atomic structure. And what does it state? It states that the entire mass of an atom is due to what? Nucleus. And what is present inside the nucleus? Protons and neutrons, which are the subparticles, and they are collectively called as nucleons. Alright, coming to mass number. Mass number is represented by capital A. And what is mass number? If you take the total number of protons and neutrons present inside the nucleus of an atom, we get its mass number. Hence, I have represented it as A equals to P plus N, where A represents the mass number, P represents the number of protons, and N represents the number of neutrons. This slide is based on calculation based on mass number and atomic number. To understand this concept, let us assume that there is an element X, alright, with mass number as A and atomic number as Z. So this element whose symbol is taken as capital X can be represented with its atomic number and mass number as it is designated in the picture. You can see it in the picture. X is representing the symbol of an element, and A, which is written as superscript, is representing the mass number, and Z, which is written as subscript, is the atomic number. All right. So we also note that number of protons means atomic number, right? So I can write it Z equals to P. And we also learned that the number of protons will be equal to the number of electrons. So we can combine and we can frame an equation that Z equals to P equals to E. It's very important. You need to keep it in your mind. Now, you know how to calculate the number of protons and electrons? Yes, you should be able to do that, because if you know the atomic number of the element, then you will easily be able to find out the number of protons and electrons, right? Then what is left? Neutrons. Yes. So how do we calculate the neutrons? It's very simple. You just take the difference of the mass number and the atomic number of an element. You'll get its number of neutrons. All right. Let's take an example. Here I have taken an example of a sodium atom. You know the symbol of sodium is Na, and the atomic number of sodium is 11 and mass number is 23. So in order to calculate number of electrons and protons, what data you'll take with reference to sodium? You should take atomic number. And what is its atomic number? 11, right? So the number of electrons and protons will be equal to the atomic number, and the answer will be 11. So how do we calculate the number of neutrons? Just have a look at the data given to you. Atomic number is 11 and mass number is 23. So to calculate the number of neutrons, we need to take the difference between the mass number and the atomic number, that is 23 minus 11, and we get the answer as 12. All right. Now coming to isotopes. What are isotopes then? Now isotopes are atoms of the same element, but they will have the same atomic number but different mass number. Just observe the example. The example is that of two chlorine atoms. In the first case, you can see that chlorine has atomic number 17 and mass number 35. In the second case, it has 17 as atomic number and mass number as 37. Observe it carefully. What is common in both the atoms of chlorine? Yes, atomic number. What is it? 17. And the mass number is different in both the cases. For the first chlorine atom, it is 35, and for the second chlorine atom, it is 37. All right. Then, what are isobars? Isobars are atoms of different elements. They'll have the same mass number, but they'll have different atomic number. Have a look at the example. Here I have taken the atom of argon and atom of calcium. All right. Argon has an atomic number as 18 and mass number as 40, while calcium has atomic number as 20 and mass number as 40. If you observe both the cases carefully, what do you notice? In both the cases, argon and calcium, the mass number is same, that is 40. But argon has atomic number 18 and calcium has atomic number 20, which is different. All right. Now, you also need to note that isobars will have different number of electrons, protons, and neutrons. You can try it with the help of the example given in the previous slide with reference to that of argon and calcium as the isobars. Just try it. Now, you also need to note that different isobars will have different physical as well as chemical properties. Coming to isotones. What are isotones then? Isotones are atoms of different element, but they'll have the same number of neutrons. Let's take an example. Here I have taken an example of carbon and nitrogen atoms. Carbon has an atomic number as 6 and mass number as 13, while nitrogen has atomic number 7 and mass number 14. All right. You know how to calculate the number of electrons, protons, and neutrons. Just try it for both the cases, that is carbon and nitrogen. What do you notice? After looking at the data, you notice that the number of neutrons in both the cases is same. So atoms of different elements which has the same number of neutrons are called as isotones. Please do not get confused between isotopes, isobars, and isotones. I hope the session is clear to you. If you have any doubt, you can message me in my personal WhatsApp, and the assignment based on this video is mentioned at the end of the video. Please try to solve these questions in your classwork copy and maintain the record so that it can be corrected when the school opens. However, I'll be posting the answer key for the assignment after few days. Thank you. Stay safe and have a